Hello guys, in this video we will look into the binary tree traversal recursive algorithm and we will solve 3 LeetCode problems. If you are new to this channel, welcome, and if you are preparing for technical interviews, consider subscribing because in this channel we talk about how to solve technical problems and also discuss about all the technical nuances for programming interviews. So in LeetCode, if you filter out based on binary tree and easy problem, you will be able to figure out 3 of the traversal algorithms. We'll look into the binary tree Inorder traversal. Then we'll use the same technique to solve the other 2 preorder and postorder traversal. So let's talk about what is binary tree Inorder traversal. So for the first example, 1, 2, 3. So let's draw this picture 1, 2, 3. We have only 3 nodes. And we want to do a Inorder traversal. So let's talk about Inorder traversal for binary tree. So if you are given a root node and there is left subtree and also right subtree, or right subtree, right? So this is the root node. So the main difference between 3 traversals are, so how you process the root value, right? So if you are doing Inorder traversal, that means you will process the root in the middle. And if you're doing preorder traversal, you will do process the root in the first step. And for the post order, you are doing in the last step. So basically what we are trying to do for Inorder traversal, we will traverse the left subtree first. Then we will traverse the root and do the right subtree. So if you understand how this traversal works, then you will be able to solve all the problems related to binary tree traversal algorithm. In this video, we will mainly talk about the recursive structure of the solution, but in the upcoming video, we'll talk about how to do it in an iterative fashion. So for 1, 2, 3, for this value, so if this is our root node, if we start from 1 here, right? So you start from this node first. Let's talk about this node first, right? And we want to go to left, and there is no left. So we'll process this 1 first. So you print as 1, and then go to the right side. And right side, you get 2, but you still have a left subtree. So you go to the left side and then print the root. So 1, 3, 2. So again, so you process, you are in this root node. For Inorder traversal, you go to the left subtree first. This is your first processing. This is your second processing, and this is your third processing, right? And 1, 2, 3, 2 is the root node, 1 and 2 can be subtree. So basically you might have another subtree here, you might have another subtree here. So when you are processing 1, then you basically go to 1A first, then 1, then 1B, right? Same thing for 3. So you go to the 3A first, then 3, and then at last 3B. To solve it using Python, so for the Inorder traversal, we basically write another recursive function. So I'll just copy this whole thing and then write a recursive Inorder traversal. So, and we'll call it something like traverse Inorder. And for this problem, we don't want to return anything for this function. And we will get a result node, which will be a list of integer. Okay, so for Inorder traversal, basically what you do, so you define your result as an empty array. You call this traverse Inorder. with the root and result, and finally return this result. And what we will do in the traverse in order, if your root node is null, then you basically return. And if you know the steps how you solve the in order, so you process the left subtree first, then the root node, and then the right subtree. So basically you call the same function self dot, and if you want to know how we do it, so you just copy this same call, right? In order, we will traverse with the root dot left, then process the root, and we'll write it here, and then call it for right node. And for processing means for the root node, you basically add it to the result array with the root dot val. That's pretty much it. So if you can try submitting these ones, so this solve the problem. So let's talk about the runtime complexity. You are traversing one node at a time, so it will be order of n for the runtime complexity. There is no extra space complexity. You are returning the result if you are not considering output as a result. So since you are returning, so there will be order of n size. But if you consider the recursive call structure at the depth level, it might be order of n maximum, right? But if you don't consider the recursive stack, then actually it's basically constant space and then order n linear time algorithm. So if you solve this problem, you'll be able to solve the other problem pretty easily. So basically, you copy this whole thing for other problem, right? The preorder problem, right? And let's make it a traverse preorder, right? And I'll just make it preorder here. And when you are doing preorder, you need to remember you will process the root at the beginning. So you are doing the process the root first, and then go to the left subtree and right subtree. And other things will be similar. You basically call the same thing with just only the preorder, right? You can just copy paste this part. So there is not that much change on the code, right? So basically the order will be different, right? Traverse preorder. So we messed up here, missed an A. Okay. Yeah, that's pretty much it. So, and if you want to do it post order, same thing. You just copy the whole thing here, make it not pre as post. And here, same thing like post order and post order. And you need to know actually which order you are doing. So when you are doing post order, you are processing the root at the last. So you do root dot left, root dot right, and then do the process, the root node. And same thing for this, you can call the Postorder traversal. Just make me change this guy. Okay. So everything looks good. So that's how you solve it using recursive algorithm. In the later video, we'll talk about how we can do it in an iterative fashion if we don't want to use the recursive structure for this problem. These three problem solution are really basic building block to solve other problems, because you will be able to use how to use recursion in your coding solutions, and also we'll take a look at the iterative solution. That's it. Thanks for watching, and we will talk about the iterative version of these three algorithms in the next video.